Now that we've talked about this, there are 3 ways to classify systems. First is by magnitude same thing as gain response, G of omega. And that's the same thing, it's defined to be the same thing as the magnitude of, whoops, I'm trying to speed up because I'm getting close to the end. It's the same thing as the magnitude of the DTFT. And based on that, we can say if it's a low pass filter or a high pass filter or things like that, band pass filter, band stop filter. We can classify it based upon its, not its magnitude response, but its phase response. And based upon that, the angle of its DTFT. And based upon that, we can say if it's zero phase, linear phase, nonlinear phase, non-linear phase. And last, we can classify it based upon its impulse response. Our only time domain. And based upon that, we can say it's FIR or IIR. And if it's FIR, the only reason why we would be willing to accept the worse power, the lower power FIR response is if we enforce it to be linear phase. And IIR is far more powerful, but we have to live with it being nonlinear phase. So I'll say, so it's good in the frequency domain. We can make very sharp filters of low orders, but bad in the time domain. It screws up the morphology, we call it, of our signals. And linear phase is good in the time domain, does not screw up the morphology, but it's very bad. It's relatively bad in the frequency domain. You need a really high order FIR filter to have the same sharp cutoffs in frequency that you do for a nonlinear phase. Just to put this in perspective though, you'll remember in EE431 when you built a 4th order low pass Butterworth filter, and that was 4th order. And that killed frequencies over 200 hertz relatively fast. When you're making these digital filters, you're not limited, of course, to the 1% accuracy of your components or the 5% accuracy of your components. You're limited to whatever your accuracy is of the numbers on your system. So if you've got an 8-bit accurate microcontroller, you can make a 10th order FIR filter easily. And if you're using floating point operations, you know, the sky's the limit. You can make a 1000th order FIR filter easily. So the fact that it's not as powerful in the time domain, in the frequency domain, isn't necessarily such a big showstopper because it just means you're going to make a really high order filter. The bad part is that just then it will introduce a significant delay.